Okay, so thank you all. We're going to get started. Thank you all for joining us. So today I'm making the introduction. It's really my pleasure to welcome Anxo Sánchez. I've been a big fan of his work for a very long time, for over a decade. I've invited him to give a talk in my lab at MIT once, and he also gave it remotely at the time. But now this is the first time we actually meet in person. And I'm very delighted that he was able to come, even though he's got some heavy teaching requirements, and some of his students are now taking an exam as we speak. So Anxo is a professor of applied mathematics, but he's one of the few people who are, despite being theory people, they're comfortable venturing into experiments, and building complex, messy experiments. And I think that's something that a lot of mathematically minded people prefer not to do. They just like to deal with simple, well-behaved integers and things like that. I think one of my favorite, as is customary when we introduce the speakers, I like us to comment on one paper that we particularly liked from the speaker. And one of my favorite papers from Anxo is that he worked on with Yamir Moreno, who's a similar kind of person. I think together they're really kind of carrying the complex systems in Spain. They're like the leaders there. And it was a paper that there was a big debate about whether the structure of networks can facilitate cooperation or not. And there's papers showing these results, papers showing these other results. This kind of network structure promotes cooperation or not. And but the theories seem to kind of say something different, or that it depends. And they just said, okay, we're just going to do the big simulation, but with people, like over 1,200 people or so. This was PNAS 2012, and they showed that it doesn't matter. And I think I really love those kind of myth-busting papers. I think because they move science so well, so much forward, and help us to focus on the things that would make a difference. So, but of course, being versatile is always moving and evolving as a scientist and showing the way and opening kind of new areas. So I'm looking forward to your talk.
Thank you very much, Iyad. Thank you all for being here. Let me just begin by telling you that as a myth-buster, that paper was a complete failure, because there's still zillions of teams, mostly from China, doing simulations on как networks allow for cooperation. So let's see if today's paper is more successful in that respect. So yeah, today I'm going to talk mostly about experiments, but they are experiments informed by theory. So I'm going to tell about work we've done with these guys here. The theory guy is Sergei Gavrilets, who is a professor in Tennessee, and Denis Tversky, who was his postdoc at the time. And then we also collaborate with Julian Vighetto. She's a researcher at the Italian CNR, the Research National Council, and Andrea was his postdoc at the time. So this is kind of an outline. I'm going to tell you what the theory Sergei proposed is about, and the theory we're trying to validate. And then we are going to discuss experiments that we have done to validate this theory. Time permitting, I will make a couple of comments on how we are, on what we are going to do in similar directions in the last couple of minutes. So let's go to the preliminaries. This is Sergei's paper. It was published in 2021. It's his paper alone. And there he proposes a theory to describe how we make decisions. Okay, so in economics, typically you get the idea that people maximize their utilities. Well, that in life, there's much more to that, as experiments show. Behavioral economics is really full with examples of that. But then Sergei had the idea that he could include that. He could extend that to include other things. And on top of that, and this is really a novelty, include some dynamics in his theory. So there are a number of things that enter into human decision making. I'm just listing a few. All those things at some point have been shown experimentally to have some influence in how we make decisions. Most of them are social, in the sense that we are influenced by peers, for instance, that we have norms, which will be a key point of my talk. we also have experience from learning. And of course, we also care about the material benefit. That will be also a part of what we will do. There's a bunch of theories that have tried to incorporate these ideas into utility functions. If you're interested in those, we have recently finished a review paper that you can look into, and there's theories that incorporate one, theories that incorporate other, several, whatever. You can have a lot of info there. So, excuse me. So Sergei's theory has basically two pillars, two key points. First one is that individuals' decisions in social situations depend a lot on their beliefs about the situation and about their beliefs about others, okay? And on top of that, beliefs themselves evolve in time as a consequence of your actions and that you're observing other guys' action. So you have to account for both. You have to account for how beliefs enter the decision process, but also how they evolve, okay? So what did he include in the model? Of course, the monetary payoffs. He included a bunch of social forces, like we like to do what the other people are doing, conformity. That relates to something called descriptive norms. In some contexts, I rather use the name empirical expectations. That's what we expect about others. I'll come back to that later. And then we also have expectations about the expectations others have about us. I will be more clear about this later. Then you can also have an authority that sends messages, and you can have learning. All that is included in the model. In terms of cognitive forces, the model will include cognitive dissonance, meaning we feel bad if we do things we don't believe in. We will also have a social projection, meaning we think that others think like ourselves, and also different logic constraints on different beliefs. This is a diagram discussing this point. So that you go from individual beliefs down here at the bottom through all these kinds of things here. You will come up with an utility function I'm going to show you in a second that guides your decisions, leads to some payoff, and that feeds back into the group behavior, which affects your social components, okay? In fact, this is an example of what I call, well, not me, what's called second order emergence. So social norms, for instance, emerge from the collective of people, and this emergent phenomena feeds back on the behavior of people and changes it. So that's really an interesting thing to study by itself. So this is it. This is the utility function we're going to test. It has a material payoff component up here. This will depend on the situation or the game we explore. Then you have the cognitive dissonance term, and for that you have to realize that we have a number of variables there. So X is the action the person is going to make, and that will depend on the game. Typically, it's a real number between some boundaries. Y is my personal normative belief, what I think I should do, based on moral grounds, religious grounds, whatever. That's what I think I should do. Then I have empirical expectations, which is X tilde. I have expectations about what others will do. And finally, the one before the last term, sorry, the third term, has to do with normative expectations. What will the others think I should do? And maybe they are even ready to punish me if I don't do it, okay? So all these terms are there. They have different contributions to the utility function in terms of some coefficients A. I'm going to show you how we will get those. But then the other part of the theory, and to me, in the end, I'm not going to do a lot of it, but the dynamics is important. So before I go into that, this was inspired by recent work, and this work I'm highlighting here is an experiment by us, which I will come back to at the end of the talk. That is down here. Okay, and here we studied a different situation, but we studied social norms. Okay, now you may ask, how do you measure social norms in an experiment? This is actually a good example of how to do that. So even if I'm at the math department, I'm a theoretical physicist. So, and you are a physicist, you die a physicist. So I don't believe in things I can't measure. So the way we're going to measure social norms was proposed by this economist here, Christina Vickery, CS in Pennsylvania. And then you have to measure these two things I already asked about, or sorry, described, empirical expectations and normative expectations. And then I will also ask about personal normative beliefs to people. The thing is that for this to be a social norm, this normative and empirical expectations should be coincident and should be shared by a bunch of people. Okay, it's not enough if I share my expectations with Iyad, for instance. We should all share the expectations. So the 3 points are key to that. So we will ask about these social norms in our experiment. And let me continue then with the utility function. It can be shown that if the payoff function here is quadratic, which is typically the case in most games, and it's a game I'm going to explore, then the action you should do comes from maximizing this utility function, and you should get something of that sort with coefficients b. The thing is that in our experiment, what we're going to see is what people do, x, their action, and from there we will try to obtain these coefficients b. Okay? And the hope is that they characterize individuals, that people have different utility functions in which some they will care more about their material payoff, some they will care more about social norms or whatever. Okay?
Sorry, one question.
Sure.
Sorry. So can you, how are A's and B's related?
It's calculus. You just have to make a derivative to maximize that, and that's it. It's a calculation.
Okay.
The thing is that we cannot measure the utility function in the experiment because we only know the actions. So we need to predict the actions and from there fit the B's. Does that answer your question?
Yeah, absolutely.
Okay, now I was telling earlier that the other thing that's interesting, although I don't really discuss them a lot because I'm so interested in the B's that I lose track of these guys, is that Sergei proposes a dynamics. This is very new because this is telling about this mechanism for second order emergence I was telling. These are equations that tell you what will be the values of the personal normative beliefs, the normative expectations, and the empirical expectations, depending on what happened in the previous instance of the experiment. So these are the evolution rules. This is telling you how the behavior you have observed affects your expectations and your beliefs. And that I haven't really seen a lot of that in the literature before. And then, of course, there's a lot of coefficients here. We will also obtain them from the experiments. I will not discuss them in detail because, like I said, I'm more interested in the B's, but I will make a couple comments here and there about them. Okay, so far, everybody happy? Any questions? Yeah.
The belief is updated following this question.
Yeah. Yeah. So, for instance, my personal normative belief will change to reduce cognitive dissonance, to be more similar to what the peers are doing. This capital X is the average action of the peers, and to conform to an authority message if there is one. That's the hypothesis of the theory. Okay? Clear? More questions? Great. So let's go to the validation, which was published last year. These papers are taking an awful lot of work to get published. There's a bunch of people that hate the idea that we can, that this utility function and these mechanisms are enough to predict. But so anyway, so exact game we're going to do in the experiment. We're going to use CPR, Common Pool Resources, which was proposed by Lynn Ostrom, the first woman that got the Nobel Prize in economics. And this is about how we exploit a common resource. So there is an optimal level of exploitation. If you and the group exploit it beyond that, it will begin to decrease. If you do not overexploit it, it will be for the benefit of everybody. This is the typical tragedy of the commons problem, in which you are thinking, okay, maybe they won't overexploit it, so I'll take advantage of them, and then everybody ends up killing the resource. So how do you, by the way, we will also study incentives. I will briefly tell you that things like this are really complicated. If you try to tell people what to do in this type of games, often things backfire. This book by Sam Bowles is really very good in terms of discussing why incentives may be bad, but there's also examples in experiments in which the more you try to push moderation, the worse the results. So just a parenthetical remark. So in the game, everybody will have to decide how much they invest, which means how much I'm extracting from the common pool resource. Okay, that's XI, that's the extraction level of individual I. The total group investment is the sum of everybody's investments. Then the production function that tells you that there is an optimal level of exploitation is this one here, is quadratic, as we want it to be in the simple derivation. And the production function tells you that for small extraction level, everything is okay, but at some point it saturates and then it begins decreasing quadratically. So that's, again, very standard. So the payoff player I gets is some baseline payoff, which is the starting money they had, times what they get from the production function, minus the cost of extracting. Okay, that's the last term. Now, how does the production function work? The production function depends on the total group investment. Everybody from this total gets a fraction that is proportional to their own extraction level. And that's VI over there. So you get, if you subtracted this much, you get this much in return. So it's shared according to your extraction level. Now, there is a social dilemma here in game theory language. There is a Nash equilibrium, which is what a rational player should do. And that's worse than the socially optimum effort, which would lead to less results for some individuals, but better for the collective. Okay, so that's why there is a dilemma here. Now, we did an experimental setup, and it's funny Jad said so, because we really end up involving very messy experiments, and this one was really messy. So we had like 300 subjects from my pool of subjects in Spain. We ran the experiment in 2021. We had the game played by groups of 6, but then we reshuffled them every now and then. So if there was some kind of behavior that would spread socially, it would eventually spread, because we had them play for 35 rounds. Now, this is a complicated game because we're going to ask a number of questions. So instead of having them come into a lab or agreeing on an online time, we asked them to play for 35 days. They could take their decision any time of the day. So at 10 in the morning next day, all the decisions were matched, and we proceed to the next round. Now, having these subjects staying in the game for 35 days, it's not easy. We had to have an extra lottery beyond paying for what they did with their decisions. We had an extra lottery of 100 euros among everybody that reached day 35. So the attrition rate was like 10%, which is not bad for this type of game. Now, for every round, we gave them 30 units, and they had to decide how much of these 30 units they are going to put on the extraction level. Okay? Nash equilibrium is 24. That's what a rational player should do. Socially optimum that maximizes the collective payoff is 14. So they are well separated. Okay? And then we ran a treatment in which we have an authority message that was just displayed in their instructions every round. And it said, just the group beneficial contribution is 14 units. Okay? Now, we follow the same scheme in our earlier paper. They ran the experiment in 35 days. We asked them about their expectations on every round. So it's really a complicated thing. In fact, they have to come the first day and they ask a battery of tests like the Big Five questionnaire, pro-social orientation value, and so on and so forth. They play for 35 days. We reshuffle them every now and then, and eventually we finish. Okay? So, important. Economists will tell you that they don't believe anything you get from an experiment unless it's incentivized. So, in our social norm elicitation, you have to incentivize it. And we did. So we pay them as a function of the accuracy of their expectations. Now, how do you do that? Well, there's a question you cannot incentivize, which is personal normative beliefs, that you have to ask them. What do you believe you should do? Okay? And we ask them every round. But then we ask them, what do you think others will do? And that we can pay because we can compare with what people actually did. And as a function of the accuracy, we pay the subject. And then we can also pay about normative expectations because we compare those to the personal normative beliefs. And again, as a function of your accuracy, we pay you. So they don't answer just whatever, there's also money at stake in these questions. These are actual, they're in Spanish because they're actual screenshots of our experiment. So when we ask them, we put them these things there to make them clearer what we're thinking. Results. Red is the treatment with message, green is without messaging. What I see here, well, first thing I see is that the action is going towards a Nash equilibrium, which I remind you was 24. People are really doing much more extraction than they think they should do. That's the second panel. That's the personal normative, personal belief. They have more or less accurate normative expectations, maybe a little bit overestimate, and they have also accurate empirical expectations. And the sad morale of all this is that their payoffs decrease as the game progresses because their extraction effort is increasing. That's nothing really surprising. This is about the variances. I don't want to stop here a lot. Sergei's theory predicts variances should decrease in some order, and they actually do, but that's a little bit of a technical detail. So my observations here, like I said, the average individual effort, which I show here, appears to be going towards Nash equilibrium. Of course, it's hard to tell. We ran 35 days, but appears. That's all I claim. Now, subjects make larger efforts than what they think they should do, okay? And they also make larger efforts than what they think others want them to do, okay? So they are not complying with the social norm in that respect. They're being driven by greediness or whatever. Personal norms, which is the second panel here, equilibrate faster than other characteristics, values around 16, 17. And the variation is highest in individual efforts. So there's a lot of different individual efforts that people do, but then they decrease as predicted. Anyway, when there is authority, this is interesting because and I will come back to this later, we observe that authority does not affect the average contribution. So if you look at the actions, the first panel, they're the same. What we observe is that it increases the variance. And that is typically, and that you have to look at the results, typically because some people follow a little bit the advice of the authority, but some people react to the opposite direction, saying, okay, people will take down their extraction efforts to agree with the authority, so let's increase ours. And I will come back to that later, but the authority message does not help on average. It just makes the world more polarized.
Sorry, can
Sure.
I ask a quick question? Authority here is not a sanctioning authority.
No, it's just this recommendation.
Okay.
Authority is the name Sergei gave it. I think it comes from his Soviet past. Yes?
Can you say again, what's the green versus
Green is without authority, without this message that the socially optimum is 14, and red is with. So there's not much of a change, as you can see. Okay, and the average payoff declines, and the message decreases the norms. That's the red curve in the second panel here. But that's mostly the effect, you see. Now, to the point I like, the values of the Bs. We cannot get a value for the effect of the authority because we just have one value for the message, which is do 14. This we plan to investigate further in new work. But for the time being, this is what we find. Without messaging, with messaging, what's the most important thing people take into account in their utility function? Personal norms, coefficient B1. Then it's empirical expectations, B3, what they expect others to do. And at a lower level comes normative expectations and money. So people are mostly influenced by their personal norms. Like I said, we cannot measure before for the message directly, but noticing how it makes decrease the personal norms, we think that the effect should be around also 0.2 or something like that, but I cannot tell you for sure. In fact, if you adjust the dynamic parameters, these alphas, betas, etc., you see that the message, which goes with these gammas here, has a lot of effect in the actions, in the personal beliefs, in empirical expectations, and in the normative expectations. So it's actually there. Now, this slide is just to tell you, this is an histogram of the values we found. People are different. So these averages I'm giving you of the Bs do not characterize a single individual. There are individuals, for instance, for whom it's very important the material payoff, and there are individuals for whom there's other things that are important. But they can be perfectly characterized with this utility function. Okay, and this is about the dynamical coefficients. Again, I'm not going to stop there. Now, what did we do? We applied clustering algorithms to the values of the Bs. And we found 3 clusters, which are characterized by extraction levels that are slightly different. Up here, there's a blue, a red, and a yellow cluster. To me, what's important is that the guys that are in the blue cluster care a lot about their personal norms. That's B1 over there, both with and without messaging. Whereas people in the yellow cluster are more or less weighing equally all 4 contributions. And for the people in red, they are more like imitators. They care a lot about what they expect others to do. That's coefficient B3. Okay, that's the red columns down there. So if you cluster using the Bs, you get this, but you can also cluster, and we did, by using their series of decisions. So we just tried to make groups of people who had similar decisions, and there you found 2 clusters, which are, again, kind of the same in terms of there's more people that care about their personal norms, there's people that care more about their expectations about others, their empirical expectations. Now, we compared with a predictive test, the social value orientation. This is a test we ran earlier before the experiment. We get a characterization for every individual, and then we separated those who are more prosocial and those who are less prosocial. And that reflects on their Bs. And that's independent. So the separation comes from this earlier test. It's not using the experimental data. But then you find that prosocial individuals, who are the pink there, care more about their personal normative beliefs, both with and without messaging. And the other guys have a lower weight for their personal normative beliefs, the guys that are less prosocial. And they care more, although it's not significant, about the empirical expectations. Now, this is funny. Rule following. This is a test invented by Sasha Boskortentov and Alex Kimbrough. It's really stupid. When I first told to Sergey, he wouldn't believe it. You just have a screen, and they tell you, you have a ball, you have to put it either in the yellow box or in the blue box. If you put it in the yellow box, I'm giving you 50 cents. If you put it in the blue box, I'm giving you €1. The rule is that you have to put it in the yellow box, the cheap one. That's it. There's no punishment, no nothing. So when I described this to Sergey and told him we should also do this experiment, he told me this is stupid. You should all put your balls on the blue box, right? The specific one. Well, yeah, but no. That's the wonderful life of behavioral experiments. People do all kinds of things. So you can really classify them as rule followers and rule breakers, depending on how many balls they put on the blue box. And if you do that, you again find that rule followers, more so in the messaging condition, care more about their personal norms than rule breakers. Rule breakers care more about empirical expectations. We also did simulations with an agent-based model to see if we could recover the results of the experiment, because reviewer number 7 asked for that, and we did the simulations and we showed that we could recover the results. That's it. So how am I doing in terms of time? So how much time I have left?
Yeah, we have 10, 15 minutes.
Okay, great. So far, what I told you is this. Material, social, and cognitive factors are important for our actions and belief. And we know that in our experiment, we can measure those and estimate them for every person. Okay, so our model-based approach with all these equations allows us to compare individuals because we can assign numbers in the same manner to them and within the same framework. So we can really compare individuals. In this respect, I can tell you the relative weights of the different factors: monetary payoffs 20%, conformity 25%, personal norms, cognitive dissonance 40%, or 20% if there's an external message, and social norms about 15%. Interestingly, due to these non-material influences, people lose 30 to 40% of their possible earnings. So this is relevant, it has consequences. Okay? Now, as to the dynamics, beliefs and values can change rapidly. For personal norms, the key thing is social influence by peers. For empirical expectations, it's learning. There is an effect of the message, but not in terms of the average value, in terms of the polarization into people behavior. And it affects mostly personal norms. So the message affects most personal norms. Okay? So possible future extensions. This is what I wanted to tell you about. There's a number of things that you should do, and here I'm going to report on work we are doing on these two, on different games and repeating the experiment in different cultures. So let me, oops, this should not be there. Okay. So further model validation. We did experiments with the same game, but in China. A group led by, sorry, his name should be there, Boyu Sang. Also a colleague of mine from the last 10 years. And my former student, Juan Ozaita, helped us running the same experiments we have done, but in 90 minutes instead of in 35 days. Because some of the reviewers say, okay, people have time to go home and think, but if they do this on a lab, very quickly they won't do the same things. And we also did the 35 days experiment in China. Results. The original one, China in black, light blue is the 90 minutes version. I will summarize the messages in a moment, but to me, the first message I see here is that the behavior is not the same, but it's quite similar, particularly between the original experiment and the 90-minute version. It's both done in Spain. Okay? So what we'll observe there is typically all four variables are higher in China. People extract more, also think they should extract more. They have expectations that people will extract more, and so on and so forth. However, messaging is more effective in China. It does make the variables decrease. One can come up with all kinds of speculation in terms of the different regimes in Spain and China, but I won't go into that. It's a fact. Messaging acts better in China. And the difference between personal norms and normative expectations are much larger also in China than in Spain, either in the 35 days or in the 90 minutes experiment. When you go to the fits of the coefficients, there you have it. I think the plots speak by themselves. You get basically similar results. I have to say the subjects in Spain are different from the subjects that ran the 35-day experiment. So they didn't know about this. And of course, the guys in China didn't know about this. Okay, now clustering, we found more or less similar clusters. We found three clusters in Spain, as I already discussed, and mostly two in China and in the 90 minutes experiment. And it again clusterizes in between people that are more influenced by the personal norm and people that are more influenced by their empirical expectations. So the results are again similar, okay? So that's in terms of going to different cultures. I'll come back to that. Now, in terms of other games, we used this game, and that was the experiment we had done in this paper I quoted earlier by Sekeli and co-workers. This is the collective risk dilemma, which was proposed by Manfred Bilinski, who's now retired from Planck, from the Max Planck Institute in Planck. And he came up with this experiment in 2008. It's a very simple experiment. You have a bunch of people, six players. They receive 40 tokens each at every round. And they have the goal that after a number of rounds, they have to gather 120 tokens, which is half of what they all have among all of them. So at every round, they can contribute a certain amount. The trick of the game is that if you don't reach the threshold, you have some probability of losing everything. That mimics the scenario in which you didn't invest much in climate mitigation, you may lose everything you have because of a climate catastrophe. There's a lot of literature about this. Interestingly, I ran a version of this among high executives in Spain a couple of years ago, minister and governmental people and whatnot. The King of Spain was there, but he didn't participate. And the result was also disappointing. I mean, in Manfred's experiment, most groups didn't reach the threshold. In this case, people didn't reach the threshold even if they were highly educated and so on. So, okay, so this is what we did in 2021, and we also ran a replication of our own experiment, okay, which has now been published. And this is what we have. Why I have HLH? Because in our experiment, we had two treatments, one in which the risk of losing everything was very high. And at the middle of the experiment, it changed to lower, 90%, 60%. And the other treatment is the other way around. It starts at 60% and then goes up to 90%. In terms of social norms, which was the aim of the paper, we observed that if you start at high risk, the norm of contributing enough is more resilient, although it decays slower. And if you start from low risk, it jumps very quickly when high risk sets in. So social norms are sensitive to risk, which is. But here we just use our sequence of data to fit the results. So these experiments were not planned for validating Sergei's theory. There you have it. So those are the Bs, the alphas. These are the four treatments, two in the original one, two in the experiment done 3 years later. And frankly, I don't see much of a difference. I can compare them with the other game. There are differences, not dramatically. Maybe it's more important here, the higher value in the personal norm coefficient for the collective risk dilemma. But in terms of the general picture, I mean, it's kind of okay. You still get more or less similar results. And to the fury of economists, you always get the material payoff is 20%. Always, no matter the game, no matter the nationality, it's always the same thing. So again, what I'm doing with this is validating a mathematical description of how we make our decision based on our beliefs that incorporates the feedback mechanism between what we're doing and our beliefs. So we're having a mathematical description of second order emergence that depends on this feedback loop. Now, for the future, we are on the progress of designing again the same experiment, but now in a number of countries, not just in China. We are planning to go 14 countries. Iyad would recognize this plot here. It's his paper on the measuring cultures through 2 billion Facebook profiles. I'm still astonished at that paper. So what we are planning is to explore different clusters of people, of countries that share similar Facebook interests. So we're trying to get samples from each one of the clusters, but also we are planning to explore another thing, which is the tight-loose norm strength. So countries that have tighter norms are very strict. Countries that have looser norms are more tolerant. This has been measured a number of times since the seminal paper by Michel Gelfand and co-workers in 2011. In fact, nobody knows how this number for the tightness score was obtained. But don't worry, because now we have obtained it again, and it's a different number that correlates with this. So countries that were tight with that number are tight with our number, and vice versa. So we plan to work on 14 countries. We are currently designing this and hopefully submitting it as a registered report in the next few weeks. But then I also wanted to mention that my interest in culture goes beyond that. And this is a project I just started, in which I have the honor and the pleasure of having Iyad as one of our advisors. It's funded by this Planck Foundation in Spain. And what we want to look at there is to the other component of social norms, which is social network structure. And here by network, I mean real relationships, not social media. We know, because we have done that in previous works, that if I know the social, the structure of the social network of a person, I can predict with quite some accuracy, it's his or her nationality, much better than at random, just knowing the structure. So we know culture conditions the structure of the social network. Now, this is the third leg in my research program. It's behavior, norms, social structure. We are wanting to understand how the social structure actually depends on network, again, by exploring these two types of tight, loose countries versus the culturally different countries. And this is something we're starting now. I hope I'll be able to come back and visit and tell you about this in a couple of years. And that's it. Thank you very much for your attention. And if you have any questions, I'm ready.